today. Of course, as always, you guys, if you have any questions, please feel free to unmute yourself and ask me, or just put it in the chat. But let's go ahead and hop into our last set of formulas that we're going to be working with. So we've done the sum and difference identities, the double identities, and now we're doing the half angle identities. So most of the time when we see these half angle identities, we often see it like this. So even in our textbooks, like in our traditional pre-cal textbooks through the school district, they have it written like this. However, Edgenuity doesn't use it like that. The formula that they want us to use for tangent is going to be plus or minus the square root of 1 minus cosine of theta all over 1 plus cosine of theta. So use this equation as you guys are going through this lesson. This is going to be the equation that they use. So stick with this one, because otherwise your answers will look different. Now, in the end, they're all equivalent. They're just different ways to look at it. Something else I want to point out to you guys. Did I start the, make sure that I have the recording on? I do. So the other thing I want to point out is, where did I put the formula sheet at? The formula sheet that I have for you guys, they wrote it a totally different way. So I want to point it out. I went ahead and just wrote it in myself. So the way that they wrote these is they wrote it as sine squared. They changed the way that it looks. It's actually still equivalent. It's just another way to look at it, but we don't often use it in this format. So this is what I went ahead and put it next to it so that I have it handy. So that's what I would recommend. That formula sheet that I gave or told you guys to print, they don't do the half angles in the way that we will use them. And again, it's important for us in regards to Edgenuity to use them this way, because that's how your answer choices are going to be provided. So you want them to match up. So again, for tangent, use this one. These are going to be as is, so you're good there on those ones. All righty. So if you have any questions about that, let me know. But these are going to be the 3 formulas we're referencing. These are correct. We're just not going to use these. So I'll make a little note of do not use this one and this one in Edgenuity, but they are valid formulas. Okay, first one. So how does this work? So it says, which of these expressions is a simplified form of all of this yuckiness? Ew. All right, so let's take this piece by piece. So I'm going to go ahead. I'm going to rewrite it. So I have my sine of x all over 1 minus cosine squared of x times my tangent of x over 2. Okay, so I just copied it just so I had more space. It's kind of centered in my paper. I haven't done anything, but what are some things that I know? Hopefully this looks familiar because we've used this lately, and this was our Pythagorean identity. This is a Pythagorean identity, and that goes with the idea of remember our sine squared x plus cosine squared x is equal to 1. That means that if I move my cosine over, this piece right here is equal to sine squared of x. So I could go ahead and rewrite this as sine of x all over my sine squared of x, right? This piece right here, this piece, oh, so now I'm going to kind of mess myself up because I say that they use this, they do. But for this case, in regards to simplifying, it's going to be ugly. So I'm actually going to use one of these after I just put don't use it. Okay, when you're evaluating, when it says like define the exact value, they're going to have it in this format. In this case, I'm simplifying. So if I use this one, it's just uglier to work with. So if I'm going to simplify, I'm going to pick one of these two, again, just because it's easier to work with. No other reason than that. And so I'm going to go ahead and I'm going to choose my sine of x. I'm going to choose this one right here, all over 1 plus cosine of x. Remember these x's and thetas, they're just a variable, they're interchangeable. Okay, so again, I want to use this if I want to find the exact value. Simplifying, I could still use this, it's just going to take more work. And I know if these are all equal, I'm going to use one that's going to be easier to work with. So the second question then becomes, why did I pick this one and not this one? Well, I was looking ahead and I see that there's a sign squared here in the denominator. So I wondered, in my head, I was thinking, if I put the sign squared up in the numerator, can I simplify it? So could I simplify it? And the answer is actually going to be yeah. If I look here, I have a sign. This gives me, and then we'll write it out. Some of you guys already see it. So a sine of x, and the sine of x is a sine squared of x all over. I have a sine squared of x times 1 plus cosine of x. And these sine squared of x's can cancel out. Now, when I cancel it, it still leaves a value of 1 in my numerator. It doesn't become nothing in there. And so when I simplify this, I end up with 1 over 1 plus cosine of x. So I could simplify this piece because remember, it's sine of x times this quantity. If it was a plus or minus, then I couldn't simplify it. And so I could go ahead and match this up with this piece right here. So kind of a tricky problem, especially after I just said, don't use this, and then I'm using it. So when I'm going to evaluate, their answers are like this. I do have a problem. Is it on today's? Oh, they do have a problem today that will use that, so that's good. I definitely have one tomorrow too, since I already did the video for tomorrow. Okay, so how do I use this? So this one says, what is the exact value of this 157.5? So again, exact value means it's got to be on my unit circle. And I'm thinking like, okay, well, I definitely know that's not on my unit circle because it has that 0.5. And even if I use the sum and differences, there's not two numbers that I can break this into that are going to add to that are on the unit circle, especially with that 0.5. You know right away that there's nothing, because there are no decimals in any of these degrees, that I can add or subtract two values to give me this. So I can't use my sum or difference identities. Not going to work. So that's where this idea of this half angle comes in. So what is this telling me? Well, let's look at this. If I say that this is going to be my theta over 2 value, say that that's theta over 2. In other words, this is going to be equal to sine of theta over 2. So 157.5 has to equal my theta over 2. All right, so my theta over 2 is going to equal 157.5. If that's the case, can I solve for just theta? So yeah, I can multiply this by 2, and what I do to one side, I do to the other. So this would cancel out, and this tells me that theta would equal 2 times 157.5 is 315. This number is on my unit circle. This is a good sign. If that happens, if I solve for theta and that value is on my unit circle, then I can use my half angle formula. And if I look here, sine of theta over 2 is equal to plus or minus the square root. So I'm copying this equation down right here. So it's equal to plus or minus the square root of 1 minus cosine of theta all over 2. All right, so I need to figure out, is this going to be a plus or minus? Is this going to be a plus or minus? How do I know if it's going to be plus or minus? Well, we're looking for sine of 157.5 degrees. So if I look at my quadrants, 157.5 would be in quadrant 2. This is 90 degrees. This is my 180. So all students take calculus. I'm in quadrant 2 because the value that I'm looking for sine of 157.5 degrees is in quadrant 2. Sine is positive. If sine is positive, then we want this positive value. So I have sine of 157.5 degrees is equal to positive square root 1 minus cosine. Now I have this theta value. This right here is not theta. This was theta over 2, remember? It's theta over 2. Theta is 315. So theta, this theta value is 315. That's what this value is right there. It's 315 degrees divided by 2. So sine of 157.5 is going to be the square root of 1 minus 315 degrees, unit circle, cosine of 315. So 315, I'm looking at my cosine value. It's the square root of 2 over 2, the positive square root of 2 over 2 divided by 2. This numerator has 2 terms. So if I want to write it as one term, then they have to have a common denominator. So instead of a 1, I'm going to write this as 2 over 2 because 2 over 2 is still a value of 1. And when I do that, then I can rewrite my numerator as 2 minus my square root of 2 all over 2 divided by 2. Yes, this is ugly. That's okay. That's okay. Because look what my next step is going to be. If I'm dividing by 2, 2 over 1, it's the same thing as multiplying by the reciprocal. So I'm going to multiply this by 1/2. So I end up with the square root of 2 minus square root of 2 all over 2 times 2 is 4. The square root of 4, I know, is just going to be 2. So I could write this as the square root of 2 minus the square root of 2 all over 2. This 4 can come out of the square root. Now the numerator, I can't do anything with it. It's ugly. It's okay. You don't need to do anything special with it. You leave it just like this. That's it. So it's ugly, the answer is ugly, but you don't have to try to rationalize it or get rid of the double radicals. It's going to have that. That's our answer. This piece is the final answer. The only thing we need to make sure is that if that square root of 4, if that value of 4 is under the square root, we can simplify that to just the value of 2. So my answer is going to be this right here. So again, that was a lot to take in, especially for the first time seeing that. So let's go ahead, let's look at another one. So the main idea here is you're going to need to figure out what are the theta values. That is not the same thing as the number that you're given here, because that's always your theta over 2. All right. My next one. So Jacob performs the work shown, to find tangent of 165 degrees. All right, so let's kind of look at this and see what's going on. So the first thing is this value is my theta over 2. So if theta over 2 is equal to 165, then theta is going to be what? So I multiply both sides by 2, and I get 2 times 2 times 165 is going to be 330. Okay, so I know my theta value. The second thing we're going to need to know is what quadrant is our original value in. So I look here and I'm 165. So all students take calculus. So if it's 165, we're going to be in quadrant 2, which means if we're talking about tangent, I know it's going to be a negative. And I'm going to go ahead, I'm going to write the formula that they're using. So this was the one that's on the front side of the paper, just so we can use it to compare. So tangent of theta over 2 is equal to plus or minus the square root of 1 minus cosine of theta all over 1 plus cosine of theta. All right, so I want to make sure I have that because we're trying to see, well, where did he go wrong? Where did Jacob go wrong? So I look here and I know, okay, well, it is a negative because it's in quadrant 2. And since it's tangent, it has to be a negative value. And I look here at the theta value that they plugged in. The theta value is 330. So we're good there. But some of you guys might notice right away, and they try to trick us because it's a small mistake. But look at this right here compared to here. The signs are switched. So it was just a silly little mistake. It didn't even have to do with figuring out these values or anything like that. It was right away that they messed up. They switched the signs for the formulas. So I recommend when you do these problems, write the formula down so you can literally follow through with each step. Because if you look at this and you just kind of glance at it, you may not catch that. So it was just a little mistake, and it's something that's common. So it's a drop-down bar, which is kind of nice because it's going to be written a certain way. But it says something to the effect of cosine expressions are reversed. All righty. So we're looking for the values on the unit circle. So we're looking for the exact values of this equation. Well, this is ugly. I have all kinds of stuff going on. So I go here and I look and I go, okay, well, this is going to be a half angle, right? So I know that this piece right here, I'll just write up here, that sine of x over 2 is going to be equal to plus or minus the square root of 1 minus cosine of x all over 2. That's what this piece is. Okay, so let's go ahead and let's work with this. Let's plug that in and see if I could come up with some way to go about it. This is tricky because I look at this and I go, ooh, this is ugly. I look at this and I go, ooh, that's ugly because it's got the radical. So let's see where we can go. So this piece right here from my half angle formula tells me it's going to be, I have plus or minus the square root. I don't even know if it's a positive or negative because I don't know what this value is. So I don't know what quadrant it's in. 1 minus cosine of x all over 2 plus cosine of x minus 1 is equal to 0. Okay, so here's the deal here. I don't like this radical, and the only way I know how to get rid of a radical is to square it. But if I just square this like this right here, then this would be saying I'm squaring these three terms, so it would be all of this times itself, and then I would have to FOIL it out, and it would be a ugly, ugly mess. So my thought is, can I get this piece by itself? Can I just get it by itself? Yeah, here's the way to go about this. If I want to get this by itself, why don't I just move this over to the other side? Well, how do you move this over to the other side if it's a plus or minus? Well, I'm just going to add and subtract it, which means it's still going to be a plus or minus over here. So it just would be cosine of x minus 1 is equal to, it's still going to be a plus or minus, because if I subtract it from the plus and I add it to the minus, it's going to be plus or minus. So it's 1 minus cosine of x all over 2. The reason why I did that, if I got it by itself, I can go ahead now and I can square each side. And when I square each side, when I square this, this plus or minus squared has to be a positive because a negative squared is still a positive. So this is going to become a positive, and my square root and squared cancel out. And I have now just 1 minus cosine of x all over 2, which looks way easier to work with. And then the question is over here, well, what does this become? Remember that this piece is going to be cosine of x minus 1 times cosine of x minus 1, and we need to distribute this through. So when I distribute it and combine my like terms, I end up with cosine squared of x minus 2 cosine of x plus 1 is equal to 1 minus cosine of x all over 2. Okay, you guys with me? I know this is a lot. Okay, I don't like fractions either. So I worked to get rid of the radical because that was hard to work with. The other thing that makes this hard to work with is this fraction, this 2. That's an easy fix though, because if I want to get rid of this 2, why don't I multiply it by 2? But what I do to one side, I have to do to the other. So I'm going to multiply everything over here by 2. So these 2's cancel, and these just all get multiplied by 2. That's easy. We can easily do that. So I end up with 2 cosine squared of x minus 4 cosine of x plus 2 is equal to 1 minus cosine of x. This is something that we can work with now. This is going to be just like a regular linear equation or regular quadratic when we work with just our x's. So I want to get everything set equal to 0, and then I'm going to end up factoring. This is what you guys are probably more able to recognize and work with. So here's what my next step is. I'm going to subtract 1 from both sides. I'm going to add cosine of x to both sides. So that when I do that, I end up with 2 cosine squared of x minus 3 cosine of x plus 1 is equal to 0. And all I want to do now is factor this. This is the same thing. It's like working with 2x squared minus 3x plus 1. So your x is just representing that cosine value. And all I need to do is just factor. So I need two numbers that multiply to 2 and add to a negative 3. So it's going to be negative 2 and negative 1. But remember, we have a coefficient there other than 1. So I want to divide both sides by that coefficient of 2. This simplifies to negative 1 over 1. So this is my, remember, instead of x, it's cosine of x. So this is my cosine of x. And this factors into 2 cosine of x minus 1, 2 cosine of x minus 1. This one is 1 cosine of x minus 1. I don't need to write the 1, so I could just write this as cosine of x minus 1 is equal to 0. And I set each one of these equal to 0, and those are going to give me my solutions. So I have 2 cosine of x minus 1 is equal to 0. Add 1 divided by 2, so I'm going to get my cosine of x is equal to 1/2. Over here, I'm going to have cosine of x minus 1 is equal to 0. So cosine of x is equal to 1. So when is cosine going to be 1/2? So I'm looking for cosine to be 1/2. It's here at 5 pi over 3, and it's here at pi over 3. So this one's going to be x is equal to 5 pi over 3 and pi over 3. When is cosine going to be a value of 1? It happens here when x is equal to 0. So these right here are going to be my solutions. It says check all that applies. So we had 0, we had pi over 3, and we had 5 pi over 3, and you're done. That's what they're looking for. So this was a tricky problem. It had a lot of steps. It had things that you may not have thought about doing, about getting that square root by itself to get rid of it. So use this. If you come across an ugly problem like this one up here, grab this out to help guide you, to come up with some strategies of like, well, where do I go from here? What do I do? Because these are going to be the steps that you'll see repeating throughout these. All right. This problem right here is very, very similar to what we already saw up here. The difference is that we had to get that sign of x over 2, that value, onto the other side, where here they're already giving it to us like that. So let's see what happens. So they made this easier for us. So again, this one's looking for solutions that are going to be in degrees. So pay attention to how your answers are. This was going to be radians because it's 0 to 2 pi. This is going to be in degrees. So again, here's my half angle. For cosine of x over 2, it's going to be plus or minus the square root, and it's going to be 1 plus cosine of x all over 2. So the difference between sine and cosine is this sign right here. So when it's sine of x over 2, it's a minus. So sine of x over 2, it's a minus. When it's your cosine, it's a plus. That's the only difference. So that's going to be equal to cosine of x plus 1. Okay, so again, we need to solve this. I have that ugly radical. I don't like it. So just like we did on the last problem, let's get rid of it. And the way to get rid of this square root is to square it. But what I do to one side, I have to do to the other. So a negative squared is going to be a positive squared is a positive. So this is a positive. The square root and the square cancel out. And I have 1 plus cosine of x all over 2 is equal to, now remember, this is going to be cosine of x plus 1. When it's squared, it's saying it's cosine of x plus 1 times cosine of x plus 1. And then you would need to distribute this through. So you end up with 1 plus cosine of x all over 2 is equal to cosine squared of x plus 2 cosine of x plus 1. And then, of course, just like we saw above, get rid of the fraction. I don't like working with fractions. It makes things hard. So this is divided by 2. Why don't I just multiply it by 2? But what I do to one side, I have to do to the other. So these 2's cancel out, and this gets distributed through. So I end up with 1 plus cosine of x is equal to 2 cosine squared of x plus 4 cosine of x plus 2. And then I'm going to set it equal to 0. Again, same steps. Look, we squared, multiplied by 2, set it equal to 0. So I'm going to subtract 1 from both sides, and I'm going to subtract cosine of x. And I'm going to go ahead, I'm going to write that up here. So I end up with, minus my cosine of x, I have 2 cosine squared of x. This leaves me with 3 cosine of x plus 1. And it's all equal to 0. Once we do this, then we can go ahead and we can factor. We can factor. So I need 2 numbers that multiply to 2 and add to 3. And those 2 numbers are going to be 2 times 1. But again, we have a coefficient other than 1, so don't make the mistake and forget about that. That means I divide both these sides by 2. This can simplify to 1 over 1, so this is my cosine of x is always in the denominator. So this factors into 2 cosine of x plus 1, and this is going to give me a cosine of x plus 1 is equal to 0. 2 cosine of x plus 1 is equal to 0. Subtract 1, divide by 2. So I have cosine of x is equal to negative 1/2. This one gives me cosine of x plus 1 is equal to 0. So I have cosine of x is equal to negative 1. Again, this one we're in degrees. So when is cosine going to be a negative 1/2? So I'm looking for cosine to be a negative 1/2. So at negative, it's negative 1/2 here at 120, and it's negative 1/2 here at 240. So 240 as well. So was that 120 and 240. Over here, I have x is equal to -1. When is x going to equal -1? It's at 180 degrees. So I go, okay, well, this is great. I've got my answers. So I look here and I go, oh, there's only 2 spots and I have 3. Well, how do I know which ones to pick? So here's going to be your clue on when you need to worry about this. When they give it to you in degrees, this is going to be something you're going to start to think about. They don't usually do it with the radians because you guys have a hard time working with radians as it is. But here's what you need to do. So I need to do a little check. And I'm going to run out of space, so I'm going to try to squeeze it in up here. Okay, so what do I mean check? These are my values. So what happens if I say x equals 240? What happens if x equals 240? So this tells me then that cosine of 240 all over 2 has to equal cosine of 240 degrees plus 1. Okay. Well, cosine of 240 over 2 is the same thing as cosine of 120 degrees, right? So if I look at cosine of 120 degrees, cosine of 120 degrees is going to be, a -1/2, right? It's a -1/2. So -1/2 then should equal 240 is a -1/2 plus 1. Well, that's going to give me a +1/2, right? So these two sides aren't equal. That is not equal. So although it looks like it should be equal, they are not equal. They are not equal. And so this is what we would call an extraneous solution. It's a solution we solved for, but it doesn't actually work. So this is not valid. These two, I just don't have the space. When you plug them in, the two sides will be equal to each other. And so these are the two valid answers. These are the two valid answers. So this 240, we solved it. We didn't make a mistake. It just is an extraneous solution, a solution that we solved for, but when you plug it back in, it doesn't actually work. So I wanted to make sure to point that out for you. Again, they gave us the clue because there was only 2 options to choose from. Kind of tricky on if it says select all that apply. They're not going to try to trick you like this. They try to help you guys out when you solve for 3 and they're like, okay, choose these 2, the 2 that are correct. So they kind of give you some clues on when to look for those. And it's mostly going to be with degrees. I don't think they do it with any of the radians. So again, a lot to take in. This is all from your assignment today. Your quiz, I went over several problems for the quiz, which will be posted tomorrow. So I highly recommend it because again, this is a lot of information to take in. Do you guys have any questions for me today? Nobody, nothing? There's a lot, huh? All right, well, if you guys come up with any questions, let me know. Rob, you need to catch up. You're falling behind on me. I want you to make sure you catch up too before we take our test.
Yeah, I know. I was looking at that right now. I was like, dang, yeah, I need to catch up. I know this whole day I'm going to be working.
Okay, perfect, because I have a due date, and if you get all your stuff done, your notes turned in, then you guys get 5 points extra credit on your test. So,
Nice.
yes, so get your notes turned in by the due date. I forgot what I said it was. I want to say maybe it's Tuesday. I forgot. I think I said the 15th, which means you guys have the 3-day weekend. So last lesson for this chapter, which is super long, is going to be on Friday. And then the test will be next Friday. So we still have some time to review and cover some stuff, but this was a busy week.
Do we have another 3-day weekend coming up?
Yes. Yeah, no school on Monday.
Okay, I was confused. Yeah.
Yeah. So you got some extra time to work on catching up.
That's gonna be so helpful.